This lecture is about how we train these neural networks, and the agenda will be first we will just go over the basics, which will be required actually to talk about the whole process. And the basics I think we have already covered. It's just a recap. Then we will talk about optimization, and this is like the main step, which is the training process. And then we'll briefly talk about backpropagation, which is again a step which is used while training these networks. And then we'll try to cover some of the practical aspects when you do programming assignments. I think it will be very useful. And finally, I will show you like some CNN variants and like some motivations why those CNNs were designed to wrap up this lecture. All right, so let's begin with the first segment. Now, let's first try to understand the concept of network parameters. We have been talking about this a lot, but let's make sure that everyone understands this pretty clearly. So in a neural network or in a convolutional neural network, you will have input. Okay, so there is a distinction between data and parameters. Both are actually storing some values, some numbers. Okay, so in that sense, they are like similar things. But data is something which depends upon your input sample. Okay, so what value like you will have in this activation will be highly dependent upon what image you have used as your input. If let's say this is like activation map in some of the after some of the intermediate layers. Okay, so that's one thing. Then there is one more thing which is called parameter or these kernels, which will also control what these values will be, right? But these values will not change by changing your input sample. Okay, so if you have a kernel which has certain values, for example, this 3x3x3 filter, it will have 27 different values. Those values are actually representing your network. They don't represent your data or your input images. Okay, so they are part of your network. And these are called parameters, and these will be learned when we train the network. Okay, so for convolutional neural networks, these kernels will be learned. For example, in this case, these 27 different values. So how it works is we initialize the weights randomly, which means when you start your training, you will randomly select like some values for these kernels. And as you train your model, these values will be changed. Okay, so these are the parameters. And in neural network or fully connected layers, your neurons will contain like the values or the activations. But when you're trying to connect two different neurons, you will need some weights to compute those linear combinations, right? So those weights are the parameters. And again, those weights at the beginning, you will initialize randomly. But as you train your model, those weights will be changed. Okay, so these volumes are, again, as I said, they depend on the input data and also on the kernels, but these are not part of your network. This is just data flowing into your network. Now, if you look at this example here, this is the input image and the kernel which we are striding, right? The red kernel or the green kernel, that's the filter. So those are the parameters. Those are the weights which will be learned. So we'll try to learn this filter. And again, this we just saw in the previous lecture. These are not weights. All these are just activations. And this is kind of a data flowing into your network. And this will vary with the input image you have. But how you obtain these activation maps using these convolution operations, those are the network parameters which we are going to learn. Okay, so a general CNN architecture, as you all know by now, you have input image, you have certain convolution layers, some subsampling layers, or some normalization layers, and your data will flow in your network. You go from feature maps to feature maps, and finally the output. And the way it works is you have your input image, and as I said, you initialize these kernels randomly. So even without training your network, you can actually have an input image, and you can still get these activation maps, and you can get some kind of prediction. But since the network was randomly initialized, it was not trained, what will happen is you will get some kind of output which will not mean anything. I mean, it will not be the right prediction, right? So then the whole idea about training is you take that prediction, whatever that is, we don't care about that, and then try to compare that with the actual ground truth, okay, the value which the network should have predicted. And then we try to say, okay, this seems like a bad prediction, or this seems like a pretty close, but it needs to be improved, right? So we can kind of estimate like how good the network's prediction is. And what we do is we design like a loss function, which tells you how good your network's prediction is. And then based on that estimation, it will just give you one value, how good your network is. And that value will be used to update all the network weights. So there's like a backpropagation here, which goes backwards. And there is a feed forward operation, which happens when you start with the image, apply the convolution, get this feature map. So that's called like the feed forward, going forward, getting the prediction. Okay, so there are two operations when you train your model. We'll talk about that in more detail later. So the basic training operation, I think, again, we have covered this in the past. You have your training data. So you don't train just on single image. You train on lot of images. And that's one of the limitation of deep learning. You require a lot of data. Okay? So you have all these images and you can extract features, or you can use like CNN to extract features. And then you need these labels, which are called ground truths, right? So then again, for all these samples, you try to make predictions, and then you make use of these labels to say how good the network is doing. If it's doing bad, you will penalize the network. You will say, okay, the weights are not good, improve the weights. So that act, when you say that improve the weights, that is called network training. Okay? So during training, all you're doing is you're trying to change the weights of those kernels. That is called network training.